So my name is Stephane. I'm working for Slice. So Slice is a small company based here in the Bay Area. And basically we're doing two main things. We have a mobile app that can help you track your online purchases and also compare price. And we're also doing market intelligence. So I've been with Slice for about 1 year. And my main focus has been automation for databases, MySQL and MongoDB. So actually my talk here is only on MySQL because for MongoDB what we're doing is, it has just been released, so it's a bit more experimental. The main goal of the session here is really to help you understand why automation can be very hard. So if you attend sessions from the big players, you will always hear that everything is automated. So you may have the feeling that it's super easy. Like in the cloud, for instance, you have auto-scaling groups in AWS. Well, auto-scaling group, it means that you say, I want 3 instances, one gets scaled, another one gets created automatically. That's wonderful, you have nothing to do. Actually, that doesn't work like this. Automation is really hard. So the whole session is really about what we had, so the initial situation which was not good, what we wanted to do, and how we tried to solve the problem, and how, while solving problems, we found new problems, which were sometimes very annoying. Okay, so let's start with our environment. So the environment is not very complex. Basically, we have 5 DB stacks, so 5 masters and some slaves. The data volume is really different from the stack. So we have one very small stack with about 30 gigabytes of data. We have 2 big clusters with 2.5 terabytes of data, and we also have intermediate clusters with data with a few hundred gigabytes. And these stacks have really different workloads. So some of them are read heavy, some of them are write heavy, some of them see a mix of reads and writes. So it's quite different. But the overall architecture is always the same. We have a master and some slaves. And basically the master is always handling all the application traffic. But we do have slaves because we have some internal work to do on slaves. So we're using slaves for backups, we're using slaves for reports, we're using slaves to try to estimate the quality of our data and fix some problems. Well, we're doing lots of different things that require writing to something that is not a master, or doing heavy reads. So we're using slaves for all of that. One thing that can make the environment a bit more complex is that we have several regions. Currently only US and Japan, and of course we have several environments, QA, staging, production. So for all environments, all regions, we have all 5 stacks. So what were the problems we wanted to fix? We're fully hosted in AWS, and when the company started, we had to rely on a third-party vendor for some automation, specifically DB automation, and it worked great. Now, after some time, it became a problem for several reasons. The first one was the cost, because each instance which relied on this third-party vendor, for each instance we had to pay a premium. And when we were small and when we had a few a small number of instances, it was okay. Now, it's more of a problem. More serious issues are that for MySQL, the automation only works with MySQL 5.5. So 5 years ago, that was perfect because 5.5 was the most recent version. Today or last year, yeah, that's not that good. We'd like to have parallel replication, maybe GTIDs for easier failover. Well, we'd like to benefit from the recent feature. JSON data type would be very useful for us. We can't because MySQL 5.5. There are security issues that are very, well, now it's funny because we've moved away from this, but when we were using it, it was not funny at all. So one security issue was that we were working with 5.5, it was mandatory, but it was a very old version of 5.5, 5.5.30. Like we had that this year, last year. 5.5.30, I think it's a 3-year-old version, so not very good. And the best of all is that the DB automation only worked for MySQL when the root user, so the MySQL root user, has no password. Okay. So again, 10 years ago, that was probably acceptable. I saw a lot of systems with no root password, but it's definitely not something we wanted to have. And another problem was there was no option for failover. So if the master fails, well, of course, we can redirect the traffic to one of the slaves, but then basically we have to discard every slave and rebuild them from scratch, which is not a problem for the cluster with 30 gigabytes of data, but which is a big problem when you have 2 terabytes of data. So, well, the main goal was to create our own MySQL automation to get rid of all these problems. So the instance life cycle that we wanted to have was very simple. So we have a DBA or a sysadmin who creates an instance from a template. The instance gets created. The software gets provisioned automatically. So we install MySQL and everything else that needs to be installed. We provision data automatically, so we restore a backup, make sure it's done automatically. And if the instance is a slave, we want to make sure that replication starts automatically. So basically, we click on a button, we wait, and when everything is done, we have a slave that is ready to use. So that's the goal. And well, of course, as a bonus, we would be very happy to have some failover ability. So if the master fails, we want to be able to promote a slave and have all the other slaves being reported to the new master. It seems quite reasonable. So how can we get there? Before going into more details, let's have a look at really the high-level picture, so the building blocks that we will need. So we want to create instances from a template. So here in the AWS Cloud, one reasonable option is to use CloudFormation. So I'm not sure everybody knows CloudFormation in this room. I have a slide. The next slide is about CloudFormation. To get software provision on the newly created instances, we want to use Chef simply because that's the tool we are using in the company, so we already have some experience with it. So it's pretty clear. And then we had some questionings about how to do automatic data provisioning and how to do high availability. So one option is Galera. That could seem nice. Another option for data provisioning is simply to write our own scripts. Okay. At first thought, it was not easy to decide which option is better. Same for the high availability. So if we use Galera, okay, it's built in. If not, because we have master slave, MHA looked like a good solution, or orchestrator. So CloudFormation, a few words about CloudFormation. So CloudFormation is basically infrastructure as code. So what you do with CloudFormation is you write a JSON file, and in this JSON file you can describe any AWS instance you want to create. So for instance, you can create a stack with an auto-scaling group, you can create an IAM role, you can create security groups, you can create standalone EC2 instances, and a load balancer. Any AWS resource can be described in a CloudFormation template. So that's the big benefit of the tool. Now, one problem with CloudFormation template, with CloudFormation, is that the learning curve is really, really steep. There is a lot of documentation, but documentation, it's not easy to understand where to start. So that's one thing. And then the other problem is that the language is very, very verbose. So you very quickly end up with a JSON file with thousands of lines. So with curly braces, several levels of curly braces. So when you have something that works and you want to make a change, and if you have a syntax error, oh, that's terrible, really terrible. So we had to rely on external libraries to make that easier, because otherwise you can easily spend one day just chasing why you have a syntax error. But it's very, very useful. So because of CloudFormation, because CloudFormation wants you to describe your AWS component, we had to think about which kind of components we would need. So, well, I'm a bit in advance here. So we chose MHA instead of Galera. I'll explain why just in a few slides. But basically, in our architecture, we have MySQL servers, and we have the MHA manager, which is used for high availability or for failover. So what looked reasonable was to create an auto-scaling group for MySQL servers. It's reasonable because the number of servers is highly variable depending on the stack. So for instance, if we're in QA, we probably need only one master. We don't need 10 slaves. If we are on a large cluster where lots of people are doing custom reports, we probably have one master and 10 slaves. So an auto-scaling group allows you to be very flexible. So that looks very, very reasonable. And for the MHA manager, well, that's just one instance. So let's create a standalone EC2 instance. So that's what we did. So as I mentioned before, one of the problems was how to make data provisioning work, because we wanted data provisioning to be automatic. What we really didn't want to have is a way to create an empty MySQL server and then have someone connect to this instance and run commands to restore backup and start application. We wanted that to be done automatically. So one option is to use Galera. And Galera is very nice because if you use Galera, you have automatic data provisioning and you have high availability. Everything is built in. So that's quite interesting. So we tried to evaluate Galera. Unfortunately, it doesn't work well for all our stacks. So for some of the stacks, for instance, the ones with a low volume of data, that could have been very, very good. For the larger stacks, it's not that good, and also we have stacks with too many writes for Galera, and we probably would have problems with flow control, or a lot of Galera issues. And with Galera, we would also have needed to change the application because sometimes we're doing stuff that Galera doesn't like a lot. So we discarded Galera. And, well, of course, if Galera doesn't work, the only remaining solution was to try to write a custom provisioning script. So here, in the overview is really simple. So basically, when we have master-slave, we have two types of server, well, masters and slaves. For master, actually, we're only creating a master when we're creating a new stack. So new stack means no data. So if we have a master, we don't have data provisioning. Super easy. And when we have a slave, data provisioning means we have to have a way to know where the latest backup is stored, and then we restore it and start replication. At this point, of course, there was a question which is, okay, so we have a CloudFormation template that creates an auto-scaling group. The auto-scaling group will create servers, but the auto-scaling group, it doesn't know MySQL. It doesn't know, oh, let's create a master, let's create a slave. So we have to have a way to make sure that an instance, when it gets created, it will know whether it's a master or whether it's a slave. So how can we do this? That didn't seem easy at first. So let's get back to that later. But let's keep in mind that this is something that we have to solve. We need to know whether we are a master or whether we are a slave. So we will probably need some kind of service discovery to make sure that, oh, okay, there's no master, so let's configure this one as a master. MHA. So because we're not using Galera, we have to have something else for high availability. And well, with MySQL 5.5, MHA is a very good candidate. So one thing with MHA is that you have two ways to use it. The first one is what is called the automated mode, which means that MHA will monitor the health of your master. And if it fails, it will promote a slave. And this mode doesn't really work for us because the application is not ready for automatic MySQL failover. So if we would have done that, we could have MySQL failover working well, but unfortunately the application very likely would try to talk to the old master, which would be very bad. So we chose the semi-automated mode, which means that detection of the master failures is manual, but once you have detected a failure, you have a single line to promote a slave as the new master and reconfigure all the other slaves. One thing that is a bit annoying with MHA is that MHA has a configuration file in which you need to specify all the instances in your stack, so all the instances in your application topology. So if you have a stack with one master, 3 slaves, so that's 4 instances, in the config file of MHA, you do need to have this these 4 instances. If you don't, and if you try to do a failover, MHA will simply tell you, something's wrong. I'm seeing 4 servers, and in the config server, and in the config file, I only have 3. It doesn't look safe. I'm just aborting. And this is a problem because if we go back to diagram here, the MySQL servers are in an auto-scaling group, which means that by default, we don't know if we have 1 server, 2 servers, 10 servers. So again, to fulfill this requirement, we may need to have a service discovery or something like this. Okay, fortunately, we could think of a solution which can be much easier. So in CloudFormation, you describe your components, but what you can also do is to add dependencies between components. So for instance, you can say, I want to create the MHA manager first, and then only the auto-scaling group for MySQL servers. And the idea here is that if you create the MHA manager first, the CloudFormation template can know the IP address of the MHA manager. And then it can store this IP address in some file of the MySQL servers that will be created later. And if the MySQL servers know the IP of the MHA manager, what they can do when they're being built is that they can say, oh, actually, I'm a MySQL server, so I'm going to write something in the MHA config. So this is a way, without service discovery, to make sure that all MySQL servers are registered correctly, are correctly registered in the MHA configuration. Well, of course, I talked about creating new servers, so adding new items in the config file. We also have to care about instance termination. So when an instance is terminated, we have to remove the corresponding item in the config file. Otherwise, well, the config is still out of sync. Okay, so it seems to work pretty good, but at some point we realize that, no, there's a problem. The problem is, here because it's a standalone EC2 instance. So what happens if it fails? Well, if it fails, you're no longer able to run failover, right? So it doesn't impact your MySQL servers, so that's a good thing. It's not that critical, but still, what we experienced is that in general, when you have when you have big failures, it's not because you had one failure on one instance or on one part of your infrastructure, is because you had cascading failures. So, well, it seemed likely that just the one day in a year when the MHA manager goes down, it's specifically that day that the master will also go down. So every day we would be able to do MySQL failover, except the day when we do need it. So we didn't like the idea. Okay, so if we don't like the idea of having the manager as a single EC2 instance, why not put it inside an autoscaling group? Okay, an autoscaling group of just one. But in this case, if the manager goes down, it will get replaced automatically by a new instance, and we'll have all we want. Okay, so that looks like a good choice to make. Now, again, there's a problem, because if we do that, in CloudFormation, we're still able to specify that we want to create the autoscaling group for the manager first, and then only the autoscaling group for the MySQL servers. But the problem is that CloudFormation no longer knows the IP address of the manager. Because what happens is that CloudFormation actually only creates the autoscaling group. And when it's done, it goes to the next thing in the template, which is create a new autoscaling group for MySQL servers. So there is no way in this case to make sure that the MySQL servers know the IP of the manager. So how can we register them to the config file, to the MHA config file? Again, we would need service discovery. Because with that, we could say, oh, we have a MySQL instance that comes up. Let's try to discover the MHA, the IP of the MHA manager. Oh, it's there, so let's add myself to the MHA configuration. Unfortunately, in our infrastructure, we don't have such service. So, because we need one, we tried different options. So we tried Zookeeper, etcd. That more or less worked. Now the problem was that it was an over infrastructure to manage, and well, that's a bit annoying. We're a small team. We don't have that much time to manage an extra infrastructure just for this. We also tried something else, which is DynamoDB. So basically, an external database. So we are storing the metadata in this external database. It didn't work very well because we had race conditions. Like for instance, one question was, how can you know if you're a master or a slave, right? So one thing could be you store in DynamoDB the list of all instances and also their role, master or slave. And when you create a new instance, you look at DynamoDB and you look at what you have. If you have nothing, okay, you create a master. If you have a master already, you create a slave. Now the problem is that if in your auto-scaling group you want to create two servers, two instances at the same time, well, sometimes they will both see that there's no master, so they will both try to be built as masters, and then you end up with two masters, and it's not what you want. In the end, what we did was just to discard everything and use something much simpler, which is the AWS API. And we didn't think of it first because, well, the AWS API is not, it's probably not the most obvious choice when you look at service discovery, but actually, in our use case, it works pretty well because we are using CloudFormation. So when we create a DB stack, it's a CloudFormation stack, and every component in the stack shares a tag, which is basically the stack name. And the stack name is unique. So you can very easily know from anywhere all the components in a CloudFormation stack. And if you know all the components, well, you can know the auto-scaling group for MySQL servers. You can know the auto-scaling group for the MHA manager. And so you can know the instances inside these auto-scaling groups. And if you know the instances, you can know the IP address, you can know everything. So basically, instead of using Zookeeper or etcd or so building another infrastructure, we're just using the AWS API, which is basically managed for us. So this is really simple to use. Okay, so let's get back to the MHA configuration. With the AWS API, we are now able to make instances self-registering to the MHA config. So when we create an instance, what it does is, so it installs MySQL, it does many things, and at some point, it will find the IP of the MHA manager, and it will add itself to the MHA config. The problem, so another problem is what happens when an instance gets terminated. So I touched on this a bit earlier. Again, the MHA config needs to be in sync with the actual replication topology. So if we create an instance, we want to add an item in the config. If we terminate an instance, we want to remove the corresponding item from the config. So one solution is to add hooks to the EC2, I don't remember exactly the name, EC2 lifecycle hooks. So with these hooks, what you can do is run some arbitrary code when an instance gets terminated. So with this, we could update the MHA config. The problem is that it's a bit convoluted because you create a hook, and the hook will, for instance, create a message in an SQS queue. So you have to have a script somewhere that polls the queue from time to time. And then if you have a message, you have to do something. Well, it's a bit complex, and also it's not really real time. So it doesn't take hours. But again, the problem is that If an instance gets terminated and if it takes half an hour for the MHA config to be updated, it means that for half an hour you cannot do failover. That's annoying. So we'd like something else which works faster. Let's keep that in mind, because MHA, we have other problems. One problem was, it was highlighted when I presented MHA to the sysadmins of the company, and I told them, okay, MHA, very easy. If you need to fail over, you go to the MHA manager and you run a command line like this, and it will do everything for you. And they looked at me and say, look, do you think it's easy? And well, no, it's not easy. But that's right. So the command line is not very user-friendly. You have lots of options. You need to be very careful, because if you don't, well, you won't do what you want to do, or MHA will just fail. So actually what we did was to build a wrapper script with simple options and also auto-completion. So instead of the command line above, we have something much simpler. So like dbha promote, and then new master equals and the IP of the master. And it works pretty well. And once we build that, we realized that, oh, actually, because we're building a wrapper script around MHA commands, we can do anything we want inside this wrapper script. So, and for instance, what we could do would be to make sure that the MHA config file is synced right before we trigger MHA commands. And actually, this is what we're doing. So to make sure that the MHA config is synced, it's not the MySQL servers registering themselves to the configuration file. It's not the manager polling the MySQL servers to know who they are and whether the config file should be updated. Actually, the config file, you only need it when you run an MHA command. If you don't run an MHA command, the config file is just useless. So what we're doing is that we make sure that every time we're using an MHA command, we sync the config right before. And this can be done very easily if we always use the wrapper script instead of native MHA commands. And the benefit of it is that we don't have to care about updating the config file when instance get terminated. It's done automatically for us. So if an instance gets terminated, the config file is out of sync. But we don't care, because each time we need to run an MHA command, we run the wrapper script, which will sync the config. So it's like the config file is synced all the time, which is cool. Okay, so everything is good. No, we still have problems. Because if you remember what I told you, we have slaves, and most of the slaves are specialized slaves, where we're running custom reports. On some of the slaves, we're even writing additional data. So we never ever want these slaves to become the master, because it's pretty sure that there is some data corruption on these slaves. Unfortunately, in MHA, this can be done in the config by specifying no master equals 1. Okay, so the problem is really that how can we know if a slave is suitable to become a master or not? Because again, a slave is created inside an autoscaling group, and an autoscaling group, the autoscaling group has no knowledge about the exact role of the server that will be created. The MHA manager doesn't know either, okay? the MHA manager, it's just able to see that we have some MySQL servers, but it doesn't know which one is the master, or well, it could know, but it doesn't know which one is a potential master, which one can only be a slave. So we need to change our AWS components again. So this time, for the MySQL servers, instead of one autoscaling group, we'll use two autoscaling groups. So in the first autoscaling group, we'll have the instances that can become masters. Okay, so we have the master, and typically for us, we have two instances here, what we call DB1 and DB2. So these two servers, they can become the master. And then we have a second autoscaling group for all the other slaves that will always be slaves. And with that, it's very easy now to update the config and set the no master flag when it needs to be flagged. Because we have separate autoscaling groups, so it's very easy to know that, oh, okay, this server is in autoscaling group 1, so it can become a master. This one is in autoscaling group 2, so let's flag it with no master equals 1. Okay, so at this point, it's pretty good now, because we can create an arbitrary number of MySQL servers. The MHA configuration is synced automatically. And every time we have a failure, the node or the instance is rebuilt automatically because we're using autoscaling groups everywhere. Great. So is everything good? Not exactly, because there's something we didn't address yet, which is data provisioning. So if you remember from the beginning, we have two code paths for data provisioning, the master and the slave. So for the master, very easy, we do nothing. And for the slaves, we restore a backup and then start replication. Now, again, the problem is how can we know whether this specific instance that we're building is a slave or a master? For this, we'll use the AWS API again, so which is our service discovery system. So if the instance is part of autoscaling group 2, we know it's a slave. Okay, it cannot be a master. So in this case, we'll always restore a backup. And if we're building a slave, if we're building an instance from autoscaling group 1, it can be a master or a slave. But to know this, it's very easy. We simply have we can simply count the number of instances that are existing in the group. So if the instance we're creating is the only one, that's the master. If we already have at least one instance, it means that a master has already been created. So we're creating a slave. Okay, so this is how we can know the role of a server. And because for some other parts of the code, it can be useful to directly know whether a server is a slave or a master, we add a replication role tag for each instance. So for the master, we have replication role master. For slave, replication role slave. And if we do a failover with MHA, because we can have custom scripts, we simply change this tag. So actually, we are relying a lot on tags to do lots of things. Okay, so one of the last building parts for the system is backup, is the backup software. Because if we want to be able to provision data, we need to have something that works well for backups and recovery. So basically, there are two options. One is EBS snapshots, and the second one is Percona XtraBackup. If you look at the two options very quickly, what you will find is that EBS snapshot, it's awesome. It's super simple to use. It's also super fast because you have the backups are actually incremental, but it's done in a smart way, which means that you're taking an incremental backup, but the incrementals are then merged to the existing backups. So when you restore from an EBS snapshot, it's really like you're always restoring a full backup. It's very easy. Because again, the incremental backups, it's something that can look very attractive because it makes your backups go much faster. Okay, 10 minutes, thanks. The problem is really for restores, because when you have incremental backups, usually you have the base backup, which is a full backup, and then you have to also restore increments. And that makes the whole procedure much harder, much error-prone, and also much slower. But with EBS snapshots, you don't have that. On the other hand, you have XtraBackup. So XtraBackup is a great tool, but it's very complex. You have tons of options. You have the possibility to do compression, encryption, compression, streaming. You can do mix and match, sometimes not, sometimes yes. Well, it's difficult. It's super slow compared to EBS snapshot. Like with EBS snapshots, we can easily do a backup every hour for the 2 terabytes stacks. With XtraBackup, if we want to take a full backup, well, of course, in 1 hour, it's not possible. So it's slow. And incremental backups, yes, we can use it, but it's difficult because, again, XtraBackup doesn't have this option to merge the increments into the base backup. So, well, basic option would be to use EBS snapshots. But actually, no, not really. Because what I just told you is what you can see from a backup perspective. But actually, what matters most is the restore perspective. So as a DBA, I'm happy when my backups are very fast. But I'm happier when my restores are very fast. Because actually, what matters is the restore time. When you have a crash and when you need to restore, actually, I don't care if I'm able to back up a 2 terabyte database in 5 minutes. Because if it takes 5 minutes to back it up, but like 1 week to restore, man, my boss will be angry, very angry. And if my backup is slow, but reasonably slow, like it takes 10 hours, 12 hours, but it takes like 15 minutes to restore, oh, I'm much happier. So EBS snapshots, they're great for backups, but they're terrible for restores. And the reason is that data is actually lazily loaded from S3, which basically means that warm-up time takes forever. So if you have a small amount of data, not a big deal. But when you have 2 terabytes of data, for instance, it's a real problem. So one thing I did at some point, well, because some people were really not convinced that a slow backup was a good solution compared to faster backups. So I created 2 instances on the right heaviest cluster. And so one was bootstrapped with an EBS snapshot, and the other one was bootstrapped from XtraBackup. And what I did was to try to measure the time it would take to restore the backup, start MySQL, and have replication with no lag. So seconds behind master equals 0. So with XtraBackup, it took, well, 8-9 hours, which is already quite a lot. But with EBS snapshots, I don't know how much time it could have taken, because after 2 days, I decided to stop. Because after 2 days, replication lag was still increasing. Okay. So the great thing with EBS snapshot is that you can think that the restore is very fast. So you just attach or create a new volume from a snapshot, and then MySQL can start immediately. So the restore takes 2 minutes. But actually, it takes 2 minutes because it's a fake restore. Data is not actually restored. It's still on S3. So with XtraBackup, it takes a lot of time just for MySQL to be available. But when it's available, replication can start catching up. So it's much better. Okay, I guess you got a few minutes. So the backup script you're using, it's with XtraBackup. So by default, we're taking full backups only. So we have an option to use incremental, well, not actually incremental backups, so differential backups, which is slightly different. We're not using it because even for the largest clusters, we're quite happy with the backup time. So it's like 5 hours, 6 hours, so it's okay. The backups are uploaded to S3. 5 minutes, yes, thanks. And of course, the clusters are very different. Some have lots of data, some don't have lots of data. So the backup frequency should be stack dependent. And what we do is that we have a configuration file in S3 where we can say, oh, well, let's do a backup every hour, for this stack, or let's do a backup every 5 hours for this overstack. So this is how, with the same code, we can have the different frequencies of backups. And I told you earlier that we're relying a lot on tags, or we're using tags a lot to make things a bit easier to know whether backups were successful or not, or whether backup is running or not. We're adding tags to the backup server. So we have a tag to display the timestamp and the status of the latest backup. So we can see if it's success or failure. And we also have what I call a progress bar, which is not exactly a progress bar, but we have a tag with something like 24%, 58%, 95% when a backup is taken. So that's an easy way for you or for me to know when the last backup was taken, or if a backup is taken, if it's making progress. So that's pretty interesting. Our roadmap. So the big thing is the migration to 5.7. So now that we have our own automation, we're not limited to 5.5. We still have 5.5 because we finished the migration in March. We had many other problems which delayed some of the migrations. So now we want to have 5.7. The good thing is that the automation already supports both 5.5 and 5.7, again with tags. So I can add a tag, and with the tag, my automation scripts know whether I will create a 5.5 server or 5.7 server. We want better monitoring of errors on restores. One annoying thing we have right now is that sometimes on Monday morning, sometimes someone asks me to create a server. Okay, I create it. I know that it will take like 12, 13 hours to create. So it will. I tell the guy, okay, come back tomorrow. It's going to be ready. And the next day, I go to the server, and oh, MySQL is not running. And what happened? Oh, the restore failed, and well, it was not caught by anyone. It's not monitored. There's no alert, anything. So I restart it, but again, it's going to take 1 day. It's not great. We want a better integration with PMM, so the Percona monitoring tool. We're using it, but it's not great. So the tool itself, PMM, is great, but the way we're using it is not great. Well, okay. We want to do real-time binlog streaming to Elastic file system. So the goal here is that, so we have high availability, great. So in most failure cases, we will be able to fail over to one slave. But in case of catastrophic failure, we will need to restore from a backup. And so we may lose data. So we want the bin logs to be highly available. So Elastic file system looks like a good option. Again, this is implemented but broken. And in the, not in the near future, we'll probably try to use group replication instead of MHA. And that's the end. So that's pretty much what I have for you. If you have any question, feel free. That's the time. Yes? So it will depend on the stack. So basically, as long as we have a new master, for the old master, we can wait, like for instance, if it's able to recover. Because maybe it's MySQL that crashed, and so we have to go through InnoDB recovery, and that can take some time. But depending on the stack, sometimes InnoDB recovery, it will take like 2 hours, and it may be easier to just rebuild the server. But for the larger stacks, if we wait 2 hours, okay, that's cheap, because rebuilding a whole server takes much more time. So it will depend on the situation. To do what? To make sure we don't lose data, or to? Yeah. Mm-hmm. Yeah, exactly. Yeah. Actually, if we rebuild the server, it will be rebuilt as a slave of the new master. So, yeah, exactly. Yeah. Other questions? We're running out of time, but yeah, let's take one. So with an EBS snapshot, what you can do is run flush tables with read lock, okay, then freeze the file system, do the snapshot, and when it's done, you can unlock everything. And actually, taking the snapshot, it doesn't take a lot of time. It takes, I would say, a few seconds. So, but for us, it's not really a problem because we have dedicated backup servers. So we can just log them up for some time, and it's no big deal. What about point-in-time recovery? You want to like put the point-in-time recovery to certain dates, seconds, milliseconds, right? You want a snapshot of roll forward to maybe like 12 o'clock. Yeah. So anyway, with any backup solution, if you want point-in-time recovery, you need the backup. So you need a backup and you need the bin logs. Yes, that's right. So if you have both, you can do it. Yeah, but you know where to start. Bin logs apply. Well, if you yeah, actually, what we're doing, so we have a script to do EBS snapshot in case. Well, that's the good solution. And what we're doing is to take the bin log position at the time of the backup. So this allows you to have point-in-time recovery. Okay. Thanks, everyone. So we don't have time for more questions, but if you have some, I'm available during the lunch or afterwards. Thank you.